How do we decompose a vector algebraically into its parallel and perpendicular components? Well, we would have to be given two vectors. We would be given a vector that we want to decompose and a vector that we want it to be parallel and perpendicular to. So this blue part is pronounced the projection of V onto U, or you could also say that it is the parallel component of V. The red vector describes the perpendicular component of V. I'm not familiar with another way of saying that, but there may be another notation. P6.g stands for projection. The subscript represents the vector that you're referencing for parallel versus perpendicular, and this is our input vector, the vector we're trying to decompose. So what we know is that the dot product of V and U is taken by multiplying, or by a scalar multiplication of the parallel component, so the projection times U. We can use that to write that the dot of V and U divided by the magnitude of U represents the size of the projected component, and then we can multiply by a unit vector in U's direction because we want it to be parallel to U. That's why it has to be in that direction. The unit vector is U divided by the magnitude, so we can rewrite this as V dot U over U dot U times U. Then the perpendicular component, well, because the projection and the perpendicular component add up to the total thing, we can say that the perpendicular component is the vector minus the parallel component. So let's do some examples. Decompose V into components parallel and perpendicular to W. So the parallel part comes first. We're projecting V onto W, and we want to dot V and W together. The denominator will be W dotted with W, all times W. So I'm going to type this out. People have asked me to go into more detail, do more steps. So if you want to skip through some of this because you don't want to see every single step, that's reasonable as long as you can perform all of these steps. So this is what that fraction looks like. Now we dot the numerator together. 3, 4 dot 10, 2 becomes 30 plus 8. The denominator is 100 plus 4. So we have, that is our fraction. And now we can do 38 over 104 times 10, 2, which is what? 38 and 104 have a common factor of 2, so 1950 seconds times 10, 2. 19 times 10 over 52, comma 19 times 2 over 52. Or these cancel out, becoming 5 and 26. This cancels out and just becoming 26. 5 times 19 is 95, 26, comma 1926. So that is the parallel component. That was a bit. Now we want to find the perpendicular component. We find the perpendicular component by subtracting. So the perpendicular component is the whole vector minus this parallel component. Another way to write that is V parallel. So the original vector was 3, 4. And I'm going to subtract out 95, 26, 1926. Let's get a common denominator. 26 is going to be our common denominator. So this is 78, and that is 104, minus 95, 26, and 1926. So finally, 78 minus 95. 78 minus 95 is negative 17.
Pardon me, interruption. Miss Smith to the main office, please. Miss Smith to the main office.
And now we have 85 over 26, and that's going to be our perpendicular component. Now, what's the component that's perpendicular to this? Well, unfortunately, because it's asking about perpendicular, not parallel, we have to do the parallel first and then find the perpendicular part. So, we are going to dot. Let's call this V. Let's call this U. We're going to dot V dot U over U dot U times U. So, negative I plus 2j dotted with negative 8I minus 2j over this dotted with itself minus 2j negative 8I minus 2j and yet another negative 8I minus 2j. So the numerator, negative 1 and negative 8 becomes 8. 2 and negative 2 becomes negative 4. Negative 8 and negative 8 becomes 64. Negative 2 and negative 2 becomes positive 4. And then still times negative 8I minus 2j. We have 4 over 68 times negative 8I minus 2j. We can simplify this to 1 over 60 divided by 4 is 10 with 28, 7. So 1/17, so this whole becomes negative 8/17 I minus 2/17 j. So that's the parallel component. Now we want to subtract that in order to find the perpendicular component. So V minus the parallel component. So negative I plus 2j minus negative 8/17 I minus 2/17 j. So distribute the negative and we get positives. And then we have we have overall negative 9/17 I, and 2 plus 2/17 is 2 and 2/17. Okay. So that is the perpendicular component.